Hello everyone, Nishant here from Learn QA Skill. In today's video, we will be learning about what is test design techniques, why do we need the test design techniques, and we will be discussing two test design techniques. First is the equivalence class partitioning technique, which is also called as the ECP, and second one is a boundary value analysis, which is also called as a BVA. So let's first discuss about what is test design technique. Test design technique are used while writing the test cases in order to have better test coverage and to build the high quality software. Using these techniques, testers can identify complex scenarios, generate effective test data, and design the test cases that evaluate the full system functionality of an application. So next is why do we need the test design techniques? So exhaustive testing is not possible. So we need the test design techniques in order to reduce the size of input. So now the question arises, what is exhaustive testing? So the exhaustive testing means testing the software application with all the possible input combinations. So testing an application with all the possible input combinations, that is not possible. So because of this, we need a test design techniques to generate the effective test data that can cover the full system functionality. So there are 5 types of test design techniques. First is a ECP, which is equivalence class partitioning technique. Second is a BVA, which is boundary value analysis technique. Third is a decision table technique. Fourth is a state transition technique. Fifth and last one is a error guessing technique. So in today's video, we will be discussing about ECP and BVA. So first is a ECP. So ECP is a testing technique that divides the input test data into partitions of equivalent classes, and from each classes minimum once the data must be tested. So let's assume one scenario here. So there is an age field that accepts the values from 1 to 100. So if we apply the ECP technique here, so what we will do, we will divide the input test data into the multiple classes like valid class of input and invalid class of input. Valid class means the values that age field can accept, that is ranges from 1 to 100. So that is the valid range for age field. So this is the valid class of input, and other than this are comes under the invalid class, like the values which is less than 1, that is also invalid class, and the values which is greater than 100, so that is also invalid class. So like this we will divide our input test data into the multiple classes, and from each class once the data must be tested. So here I have divided the data into 5 classes. So in the class 1 we will check the data from 1 to 100, which is the valid range for age field. And in the class 2 we will test the age field by entering the values like 0 and -1, -2, which is less than 1, which is the invalid data. And from the class 3 we will test the data which is greater than 100, like 101 or 102. Then next is a class 4. From the class 4 we will try to enter the alphanumeric values by combining the alphabets and numeric values. So this is also invalid value for that age field. And fifth class is a decimal values. So we will try to enter the decimal values and check that whether that age field is accepting the decimal values or not. So other than the values from 1 to 100, that age field should not accept the any other values. So from all the classes at least once data must be tested. So this is comes under the ECP. Next is a boundary value analysis. So the boundary value analysis is based on the testing the boundary values of valid and invalid partition. So assume one scenario here that there is an age field, it accepts the values from 18 to 40. So if we apply the boundary value analysis here, so in the boundary value analysis we test the boundary values. So what is the starting boundary here? Starting boundary means minimum value. So what is the minimum value which that age field accepts? It's a 18, and the ending boundary is a 40. That is the maximum value that age field can accept. and along with the boundary values we have to test the boundary -1 and boundary +1. Same with the maximum boundary -1 and maximum boundary +1. So if we test this input data like minimum -1, which is the 17 value, which is the invalid value for edge field, and the 18 and the 19. 18 is a minimum boundary and minimum +1, which is a 19. So it should be accepted by the edge field. And here max -1, which is a 39 value. So 39 value is a accepted value by the edge field. And the maximum value, which is the boundary value, which is 40. That is also accepted by the edge field. And max +1, which is the 41 value. So that should not accept by the edge field because that is the invalid partition of boundary. So in the boundary value analysis, we check the boundary. Along with the boundary, we check the boundary +1 value and boundary -1 value.